Kia ora Year 12 and 13. This short video is going to show you how you can use Pythagoras to help solve problems. It will also go over the reciprocal trig functions and talk a little bit about exact values. It's loosely based on Delta, chapter 33, exercise 33.4. So if you need more practice, go and do some more of those. Okay, angle alpha is between 0 and 90 degrees. Sine of alpha is 12 over 13. Evaluate the following. Well, we're not given a triangle here, but this is really a problem that you could have done back in year 11. It just uses Pythagoras, so we can draw a triangle like this. We'll put our alpha here. We know that the sine of an angle is the opposite over the hypotenuse. Right, so we remember this from when we very first did trig, or using the version that we use in level 3, sine of theta is equal to y over r. Right, this is based on our work with the circle. So in here, if we've got sine of alpha is 12 over 13, we can draw a triangle, put in a right angle and the alpha. The opposite side is 12, and the long side, the hypotenuse, is 13. Now, most of you will recognise that as a special 5, 12, 13 triangle, but suppose that you didn't. How can I find the length of that side? Well, we'll call it x, and by Pythagoras, 13 squared minus 12 squared equals x squared. 169 minus 144 is x squared, so x is equal to 5. So we've now found this side length. So we'll get rid of the x and magically put in 5. There we go. Now suddenly this looks like an extremely easy problem, just applying our definitions of ratios. So I'm going to do those on the next slide. Right, let's redraw our triangle. 12, 5 and 13. And here's my alpha. So the cosine of x is equal to 5/13. Sec of x is equal to 1 over cosine. So it's 13 over 5. Remember that sec of theta is equal to 1 over cos of theta, so we can define that as r over x using my circle definitions. Okay, right, where are we up to? C. Okay, C is tan of x. Right, so just looking carefully, that's my opposite, and that's my adjacent. So tan of x is going to be 12 over 5, which means cot of x, the cotangent of x, is going to be 5 over 12. And E, cosec of x, is equal to 1 over sine of x, so it will be 13 over 12. So just going back in and putting in the definitions, just in case you can't remember them. At this point in the topic, if you're having trouble with your trig ratio definitions, it's time to really do some delta annulate revision. Right? So cos is a over h, sec is the reciprocal of that, so it's h over a. Okay, tan is the opposite over the adjacent, and cot is the adjacent over the opposite, the reciprocal of that. Cosec is 1 over sine, so it's h over o. Okay, I'm going to go back in again and I'm going to put in the definitions from the circle. And I know that people in my class are finding this the hardest bit to fit into the picture. Right, remember all we're doing when we do trig is we're starting with a circle here. Right, its radius is r, and we can measure we can link the x and y coordinates to sine and cos. Right? So cosine is x over r, which means that sec is r over x. Tan is the opposite side over the adjacent side, which is y over x. So cotan is x over y. And cosec will be 1 over sine, so that's going to be r over y. Sometimes it can be really useful to use those circular measure definitions. Okay, now I'm going to do one more question, also based on Pythagoras. Right, so here we're given a triangle. This is based on delta 33.4, question 13, but I've changed the numbers a wee bit. So evaluate these measures. So all we've got here is we've got two sides, and we need to work out this side. So x is going to be equal to the square root of 15 squared minus 11 squared, which is the square root of 225 minus 121, which is the square root of 104. Now, I realise you want to reach for your calculators, but please don't. Okay, we can simplify that a little bit more. X is equal to the square root of 4 times 26, which is equal to 2 root 26. Remember, we did quite a lot of that in algebra. So now I'm going to whack that onto my triangle. Let's get rid of the x properly there. Here we go, 2 root 26, which gives me cot of theta is equal to the reciprocal of tan, not the inverse of tan, the reciprocal, a over o. So that will be 2 root 26 over 11. I can't simplify that. Cosec of theta is 1 over sine theta. So that will equal 15 over 11. Sec theta is 1 over cos of theta. So it's h over a. So that will be 15 over 2 root 26. Okay, that's all for this video. Remember, delta 33.4 and the explanation preceding it is really good for these problems, especially if you would like some harder ones.